So we are continuing our studies of base and derived quantities and their units in SI, the international system. So we have done so far the base quantities and supplementary quantities. So obviously the next topic will be derived quantities and their units. So let's give a small caption here to get the context. And I have said earlier that base quantities are those which have been chosen to be the fundamental quantities and their units were chosen first. We have named 7 of them. And let's see if we can make a small list of them again. They were mass, length, time, thermodynamic temperature, electric current, I'm writing in abbreviated form, and then we have luminous intensity, and of course amount of substance. These 7 were chosen to be the base quantities and their units, as you are aware of that they had been kilogram, meter, second, Kelvin, ampere, candela and mole. They have been chosen to their SI units, and they are called base units because we can construct the units of all other physical quantities with the help of the base units. If these are the 7 base quantities, just leaving aside the plane angle and solid angle, they are 2 supplementary units and quantities rather. So we can just use the units of these base quantities to construct the units of other quantities. So those quantities will be called derived quantities because their units can be formed from the base units by multiplication or division, as we shall see now. So let's go for a table once again, and we shall see how we can construct the units of derived quantities with the help of base units. So here we go for constructing a table which will be helpful for us. Let us see, there are 4 columns we have made, and I shall write down those column heads first. First is come physical quantity. We are into derived quantities here. Name of unit. The symbol of unit. Now these 3 column heads are coinciding with we had done earlier for base quantities. But now we have made a 4th column that is called unit in terms of base SI units. Unit in terms of base SI units. That is the 4th column, and we shall be seeing here in the 4th column how we can construct the units of derived quantities with the help of the base units already defined by us. So let's make a list here. First of all, speed or velocity. We shall be finding later that speed is nothing but magnitude of velocity. They are different physical quantities. Velocity is called a vector, something we'll be learning in the classes. It's called magnitude and direction both. And magnitude of velocity is called speed. So both of them should be having the same unit, and that is called meter per second. I'm writing the full name first. Meter per second, if you write it in total. Obviously, if you go for the symbols, you can see symbol of meter was M and symbol of second one S. So you should go for this and write down the symbol of unit is just meter per second. Now luckily for us, if we go to the 4th column and see that, we are seeing the unit of velocity is defined in such a way, it already shows the construction. It already shows the construction here. This could be either written as the unit of length, that is meter, then oblique or stroke the unit of time, that is second. So the construction of the unit of the derived quantity velocity or speed is already explained here, because it's the ratio or the division of unit of length by unit of time, and those two, m and s, they are individually base units. Let me choose the second one. That will also be an easy road for us. Acceleration is the next physical quantity in our mind. Its unit is meter per second square. I write the full name, meter per second square. When writing the full name, we have to be quite patient and write the whole thing. And in abbreviated form, that's very easy. And I'm sure you are familiar with this form only. Column 3 appears more familiar than column number 2, where we are writing the full names. That nobody does in writing units actually. So this is meter per second square. And once again, we have to write the same thing in the fourth column, because you can easily see construction of unit of acceleration to be the unit of length, that is meter, per the unit of time, that is second squared. Construction is just the same as the unit itself. So we can see acceleration also is a derived quantity, and the corresponding unit is a derived unit, because it can be formed by just dividing the unit of length by the unit of time squared. And those two things, length and time, they are base quantities. Let me number them. I've got quite a few of them. So speed, velocity, acceleration, done. Next is a very familiar word in physics. We'll come across that very shortly in our classes. That is force. Now this force, name of the unit, this is interesting. This is called Newton, named after a scientist, of course, Sir Isaac Newton, the gentleman who is responsible for the laws of motion and introduction of the concept of force. So honoring him, we name the unit of force as Newton. Just note carefully that the name of the unit is of course in small letters. That is not the name of the scientist. That's capital N there. But here the unit's name is in small letter, and the symbol for that is capital N. This is to honor Newton. And here you have got a chance to see the construction of Newton in terms of the base units. Let me show you here. This can be shown to be product of these units. Let me see it. kg, then I give a dot, then meter, then I write stroke second square. So we have a chance here to see how Newton is equivalent to, same as kg, the unit of mass, that is the base unit, into meter, the base unit of length, stroke, that is divided by second square. Second is the base unit of time. So we have got here three base units, kg, meter and second, which corresponds to three base quantities, mass, length and time. And you see how we construct the unit Newton. 1 Newton means 1 kg into 1 meter divided by 1 second whole square. Now this is a very nice way to see how a derived unit can be formed with the help of the base units. You might wonder at the point, I'm afraid of that how did you get it? Well, to get to that...
Hello students, you got a glimpse of our video lessons through this small lecture. We have hundreds of lectures like this one covering various topics of advanced school level and intermediate physics in our website. They are exhaustive and often accompanied by elaborate diagrams to make concepts even clearer. They are taught with passion and sometimes with a bit of fun. So, at the end of the lesson, you have a commanding grip on the subject and you are ready for the board and competitive exams. Subscribe at physicsacademyonline.com to access video lectures of highest standard on various topics of physics.